So what do you mean by salinity? What is the definition? How will you define salinity? It is the amount of salt dissolved in water. Simple, write down. Okay. Now, how will we calculate it? We will calculate it that amount of gram of salt per 1,000 grams of seawater. So if you take 1,000 grams of seawater, how much gram of salt we will get? That is how we define the unit. So write down. It is calculated as the amount of salt in grams dissolved in 1,000 grams of seawater. Okay. Or see, grams would get cancelled. So you can say how much units per 1,000 units. Clear, everybody? So write down the next point. It is usually expressed as parts per 1,000. It is usually expressed as how many parts of grams are there per 1,000 parts. And how would you denote symbolically parts per 1,000? How will you denote symbolically? Now, how much is the ocean salinity, guys? Do you know approximately? Have you heard how much is the ocean salinity? Huh? It is 35 parts per 1,000. And how would you write parts per 1,000? Now, simple. How would you write parts per 100? Out of 100, you got 50 marks. So how would you write parts per 100? 50 percentage, right? Parts per 100. So for parts per 1,000, you will add one more zero. For parts per 10,000, you will have one more zero. So the salinity of the ocean is 35 parts per 1,000. This is how you denote it, right now. It is usually expressed as parts per 1,000 or PPT. Open ocean salinity is 35 parts per 1,000. Write it like this. The open ocean salinity is 35 parts per 1,000. Now, do you think only salt in oceans is sodium chloride? No, there are almost 35 different types of salts. Okay. So let's write down. The share of different salts are, which would be the maximum? Sodium chloride. So bottom write down 1. Sodium chloride, NaCl. 77.7% of this total salts is sodium chloride. Second is magnesium chloride. 10.9% magnesium chloride. Then third, we have magnesium sulfate. 4.7% of magnesium sulfate. And at last, we have calcium sulfate. 3.6% calcium sulfate. Okay. And there are many other salts which we don't know. We need to have an idea of the first four, and we have written that. Now, what is the average salinity of the ocean, which I told you? 35 parts per 1,000. Very good. Now, how many of you don't know to swim here? Okay. If I throw you in the Dead Sea, you won't drown. Why? The salinity is very, very high. So there are places on earth where the salinity is extreme, like Lake Van in Turkey, where it is 330, 10 times the average salinity, 330 parts per 1,000. Dead Sea, it is 238 parts per 1,000. And the Great Salt Lake, USA, it's 220 parts per 1,000. So these examples you can just write down. So you can mention it when you talk about salinity. So the next topic I'm going to discuss with you is factors affecting salinity. What are the factors that affect salinity? Now, think and tell me, what are the factors that will play a role in deciding the salinity of a place, of an ocean? Low, Evaporation. Very, very true. Evaporation would be one factor. What will be the relation? If there is more evaporation, what would be the salinity would be? Higher. Very good. This, if there is more evaporation in the place, the salinity would be higher. Very true. So if you want to think, you can just think about a salt water taking in a small box and think. So it would be easy for you to relate. Then evaporation. Then what are the other factor? Mid of the continent, yes, it can be more saline because lack of water. Very good. Then precipitation, very, very true. If there is rainfall continuously happening, the salinity will decrease. Very good. Then temperature. What will be the relation with temperature? Evaporation. Very good. So temperature will lead to more evaporation. True. Then river drainage. Yeah, very, very true. So the place where the river comes and empties all the water, what will be the salinity there? Will be more? No, will be less because river is adding fresh water to that area. So that area salinity will go down. Very, very good. Any other factors you can come up with? So this is thinking. The salinity of water in a surface layer of the ocean depends mainly on evaporation and precipitation. So as we just discussed, if the evaporation is more, the salinity will increase. If the precipitation is more, the salinity will decrease. Very good. Clear? So in the equatorial area, the precipitation is more, so the salinity is little bit less compared to the oceans at 30 degree where the evaporation is more and there is no rainfall. Because in 30 degrees, air is always descending downwards, right? Surface salinity is greatly influenced in coastal region by the fresh water flow from the rivers. So you can see that many rivers in India, peninsular India, open into the Bay of Bengal, right? So at this part, you can see the salinity would be comparatively lesser from rivers, and in polar region by the process of freezing and thawing of ice. This is another interesting. So now you guys tell me, you understand what is freezing? Freezing. Water is freezing into ice. Thawing. Thawing means ice is melting into water. Now, which will increase the salinity and which will decrease the salinity? So, example, this is a glacier and this is water. Now, if the glacier, more water gets colder and becomes a glacier, we call it as freezing. And if glacier melts and becomes water, we call it as thawing. So, in which case, salinity of the water will increase when it is freezing. When it is freezing, yes, because when water freezes, it would be pure water that would freeze. Understood? Glaciers won't be salty, it would be pure water that would freeze. So the rest of the water salinity will increase because saline water requires still lower temperature to freeze than compared to fresh water. Next, when the glaciers will melt, it will add fresh water and the salinity will increase. In polar regions, by the process of freezing, you can write down increase salinity, and thawing, decrease salinity. Then wind also influences salinity. Wind also influences salinity of an area by transferring water to other regions. Wind also influences salinity of an area by transferring water to other areas. Next. The ocean currents contribute to salinity variation. So where the ocean currents flow, we'll be studying ocean currents in detail. They will take water from different regions and change the salinity of the area. Then salinity, temperature, and density. So these are the three factors of ocean that we are going to study: salinity, temperature, and density. And all of them are brothers and sisters, mean all of them are linked to each other. When the salinity temperature changes, the salinity will change. When the salinity changes, the density will change. So all of them are brothers and sisters. So they'll all change together, right? Now, the salinity, the temperature, and the density of water are interrelated. Any change in the temperature or density influences the salinity of the area. Any change in the temperature or density. Okay, so you can simply, if you take a small mug of water and there is water and you add 10 spoons of salt, the density will slightly increase. Now, if you add 20 spoons of salt, the density of the water will again increase. Okay, same way, if this salt is removed, the density will start decreasing. So, saline water is more denser than less saline water. Good question, and we'll see, we'll study in detail. So these are the factors affecting salinity. Underline all these points. These are very important. They can ask you as a multiple choice question. Underline evaporation, underline precipitation, underline fresh water flow, freezing and thawing of ice, wind, ocean current, temperature, density. These are the factors that will help vary the salinity of ocean. Now, when we study salinity, we'll be studying two types of salinity. One, horizontal salinity, where we'll study as we move from the equator to the poles, how is the surface changing? Salinity on the surface. We call it as the horizontal salinity. Second, we will be studying is the vertical salinity, how the salinity changes as we move from the surface of the ocean to the depth of the ocean. Okay. Now, you guys tell me what should happen if we move. Okay. What's your name? Disha. Right. Okay. I tie a big stone to Disha, right? And put her inside the ocean. So she's moving down the ocean like this. How will the salinity increase? And she has a meter which reads the salinity. So what do you think would be the changes salinity when Disha moves from here and reaches down? Now tell me, how would the salinity vary, guys? What do you think? Salt, you're saying as we move downwards, the salinity will decrease. Very true in the case of equatorial regions or tropical regions. Why salinity is maximum on the surface? Because evaporation is happening in the surface and the salinity will be higher in the surface. Down, there can be no addition or no removal. So salinity remains almost constant. Yes or no? But in case of polar region, cold region, the surface salinity would be lesser as compared to the salinity in the equatorial areas because there is melting of glaciers. So write down. We'll study in detail as we move ahead and we will draw the vertical distribution of salinity. Vertical distribution of salinity. Salinity changes with depth. But the way it changes depends on the location, whether it is near the equator, whether it is in the middle, or whether it is near the poles. That would determine how it changes. Salinity changes with depth, but the way it changes depends upon the location of the sea. Next point. The salinity at the surface increases by the loss of water to ice or evaporation. What do you mean by loss of water to ice? Freezing. When it happens, freezing, the rest of the water on the surface, salinity will increase. Clear? Or evaporation. Evaporation will also increase the salinity. Or decrease in salinity by the input of fresh water from rivers or melting of glaciers. Next. Similarly, at depth is very much fixed. Now, we said In the surface, there can be changes. Salinity can increase with evaporation, decrease with precipitation. But as Disha is moving downwards from the ocean, she can see that the salinity is almost constant. Why? Because there cannot be any addition of salt or there cannot be any removal of salt there. Salinity at the depth is very much fixed because there is no way that water is lost or salt is added. There is no way to remove water from the ocean bottom or add salts to the ocean bottom. So there is a marked difference in the salinity of the surface and the deep zone of the ocean. So there is a great difference between the salinity which we see in the ocean surface and the salinity that we see in the ocean bottom. Let's take, everybody, please listen. You can draw this and we'll write it. Now let's first take tropical regions. Tropical regions means almost 20 to 30 degree latitudes. Okay. Now what is this graph showing? Here it is showing salinity, which is moving from low to high, and here it is showing depth. Okay. So first we are taking Disha and tying a stone on her back and putting her down around 20 to 30 degree latitude in the ocean. So at the surface, she can see that it is maximum salinity is there. Why? Because 20 to 30 degrees, the air is descending. There is no rainfall in this region. We have studied this, why we see deserts in this region. Subtropical high pressure belt. Heat is there, evaporation is there. Understood, everybody? Yes or no? Yes. And she can see the salinity is maximum. And when she reaches the bottom, she can also see that the salinity is almost constant. Can you see the salinity almost constant? Clear? And in between, there is a transition zone where the salinity changes the maximum. This transition zone where the salinity changes the maximum is called as the halocline zone. Now we again pull Disha out and we take her over the equator, 0 degree. And we again drop her with a stone. Okay? What will happen? She saw that the surface salinity is high, but comparatively lower from 20 to 30 degrees. Why? Very, very good. There is daily precipitation happening near the equatorial regions. We studied the equatorial type of climate, right? So fresh water is getting added. So the salinity is comparatively lower as compared to 30. Now again it is salinity is here, and at the bottom the salinity is remaining constant. In this zone where there is transition, we call it as the halocline zone. Clear? All okay? And now we again take Disha out and we drop her near the poles, higher latitude, 60 degree. She's almost dead. Okay. Now see, this is an area where snow would be melting and lot of fresh water would be adding. So the salinity is comparatively low here. Right? Again, bottom it is constant. And this is called as the transition zone or halocline zone. Is this figure clear, everybody? Yes? But usually we say we take this case where the surface is high temperature, high salinity at the top, and it goes on decreasing and then it becomes constant. Now draw this diagram very beautifully and mark all the 3 lines. The yellow is tropical regions, red is the equatorial regions, and blue is the high altitude regions. Halocline zone. The transition zone between upper maximum saline layer. So we'll be usually going with the tropics. So upper maximum saline layer and lower zone of minimum salinity, the transition zone is called as halocline zone. The transition zone is called as the halocline zone. The other factors being constant, increasing salinity of seawater causes its density to increase. So I told you, when salinity, you take a simple example. So whenever you get confused with a concept, try to imagine a small vessel with water and you adding salt to it. That will make your concepts clearer. So when you add more salt, the density of the water will increase. Yes or no? Yes. So this is the ocean surface where evaporation is happening and the density will increase. So when the density increases, this water will start moving downwards, forming vertical currents. So we understood salinity in detail. Now, which salinity were we studying till now? Vertical salinity. Now, what about horizontal salinity, guys? What would be the salinity variation as we move from the equator towards the poles? What can you guys tell me about? Now we have taken Ashley, right? And we have put a motor in her back and we have kept her here, and she would be propelling very fast from the equator to the poles via ocean on the surface itself, like a jet ski. Choo, choo, choo. So what will the salinity variation will she see? Increases. From equator to the poles, the salinity will increase. Come on. We studied about this here also. See, at the surface, where is the salinity high? Tropic. Salinity is low near the poles. So how can it increase? So we can say a general statement that the salinity will decrease as we move from the equator to the poles, right? But there are exceptions. As we said, in equator, there is lot of fresh water getting added. So the salinity is less compared to 30 degrees, where you can see maximum salinity. Can you see it? Yes or no? And salinity would be high in areas where there is no mixing of water, like the Mediterranean Sea. There is no mixing of water. If there is proper mixing, salinity would be reduced. Yes or no? So the red color is maximum salinity and the light blue color you have the minimum salinity. So you can see as we move from the equator to the poles, the salinity is going on decreasing with some exceptions that we will write down. Horizontal distribution of salinity. Salinity decreases from equator to the poles. Salinity decreases from the equator to the pole. Okay, but what is the exception? The highest salinity is not found near the equator. It is found between 20 to 40 degree latitudes. So write down. The highest salinity is not found in the equator. Highest salinity is found in between 20 to 40 degree latitudes due to high temperature. There is temperature is high, yes or no? High evaporation and very low rainfall. So these are the three factors why 20 to 40 degree has the highest salinity. Okay, temperature is very high, evaporation is very high, and very low rainfall. Simple, powerful. So we have studied salinity, we have studied vertical and horizontal salinity. So this question was directly asked. This question was asked in mains 2017. It said, explain the ocean salinity and the significance of salinity. So ocean salinity, when you explain, you will write down what is the average salinity, what are the salts that are found, how is the vertical salinity changing, and how is the horizontal salinity changing. Clear? Now we'll go to the next topic, significance of salinity. Write down. Significance of salinity. So if there is a change in salinity, what all effects will happen in the ocean is what we are going to write it down. So write down first, the marine organisms are affected due to the change in salinity. So sometimes if there is no enough salinity, the shell formation of organisms gets hindered. So they affect coral reefs and all shell forming organisms. And it also, if it is very high, it affects them. Next, physical properties of ocean like temperature, density, boiling point, flow of current, etc. depends on salinity. So all these will get changed if there is a change in salinity. What all? Temperature, we said salinity and temperature are related. Now, before Tilotima asks me, I'll tell you how it is related, temperature and salinity. So, if a water is pure, it will evaporate faster. But if the water is saline, it would need more higher temperature to evaporate. Understood? Salinity and temperature are related. Then, density, boiling point, as I said, boiling point, flow of ocean current, etc. will depend on salinity. Okay? Next point. Boiling point of saline water is higher than that of fresh water. Okay? This statement has been asked. More saline water freezes more slower than less saline water. If you take two bowls, one pure water, one saline water, and put that in the freezer and keep checking, the pure water will freeze faster. Saline water will take more time to freeze. So do this experiment today, right? So that you'll remember it every day. The salinity increases the density of water, which in turn creates ocean current.